Well, welcome to my talk. There is a lot of stuff to cover, but I hope that you really enjoyed the keynote. I really thought it was really well done. It was pretty exciting. It's good. It's a nice, cozy room. So if you have any questions at the end, feel free to ask me. But there's a lot of content. But I'm guessing you're all here because you're converting to using Unreal Engine. Good choice. Uh, so let me first start by saying, hey, welcome. This is not a editor parity talk. This is not. I'm not going to be saying like, hey, here is the outliner and here is the hierarchy in Unreal Engine and the project setting. That's not what I'm going to be doing. This is more on things that I wish was told to me when I switched to using Unreal Engine from Unity. So really, the agenda of today's talk is this. I'll just do a quick introduction about myself. The meat of this talk is really about what are the technical expectations when you're making a mobile game and when you're making a cross-platform engine game using Unity and Unreal Engine as factual differences that you will see between these two engines through the lens of these technical expectations, and then finally ecosystem and what your next steps could be. So about me, I am Arvind Neelakantan. This was a very fresh photo I took yesterday. And I am a solutions architect at Epic Games. I've been with Epic for the last 4.5 years. I am typically focusing a lot on mobile and optimization and also on the automotive stuff because automotive deployment of Unreal Engine on, say, HMI is also very close to mobile itself. I also happened to work at Unity previously for about 4 years, where I was heading technology for the Indian subcontinent and Southeast Asia. So I know a bit about moving from Unity to Unreal Engine, both professionally and as someone who's paying my salary. So mobile is very, very important for Unreal Engine. And we have been doing a lot of work within the editor to make Unreal Engine as attractive as it can for mobile game development itself. Hey, welcome. Welcome. Now, you can take a look at this documentation, which is pretty cool, where it talks about all the editor parity stuff that I was talking about earlier, where you can just learn about how Unreal Engine and Unity are very similar-ish when it comes to the editor, at least the base editor interface itself. You can learn more about that from this QR code. And it is not just me switching from Unity to Unreal Engine. There's actually a lot of studios who are switching to using Unreal Engine, and you can learn a lot about their stories and why they made the switch to using Unreal Engine by checking out this QR code. All right, with that, let's get into the meat of this talk, which is when you're making a game, when you're making a mobile game, this is a template I like to see, a lens through which I would like to see the engine that I'm going to be using making my game. And that is, what are the technical expectations of that? First off, you shouldn't have to branch your code base in order to be making a game based on, let's say you're making a PC console game and you're making a mobile game. You shouldn't be maintaining two pieces of code. It should just be the same project that you're working on. So from that lens, there are 4 quadrants that I typically like to look at. The first is developer efficiency. How fast can you make your game? What your editor workflows, what your deployment is, and so on. What's going to be the tools that's available for you to help you manage your assets, manage your memory, manage your and manage optimization in general. What's the visual fidelity that you're able to get? And that is usually something that you'd like to get your engine or have your engine do most of the heavy lifting on it. Where you just want to add a light, it should just work, right? You shouldn't have to think too much about it. And finally, any kind of third-party support which involves in-app purchases, notifications, ads, and so on. So through this lens is what this entire talk is going to be all about. Now, I want to state that this is going to be factual differences talk, right? This is not my opinion. This is not like saying dissing one engine or the other. It's both are really cool engines, and they both work in 2 different ways in most parts, and there's also similarities that would exist between those two. And I'm here just to show you the factual differences between it. So let's start from the very beginning. Let's start with developer efficiency. Now this is Unity. Let's play an empty scene. Now if I create an empty scene within Unity, So I just go in here and I click play. As you would expect, this is just going to show an empty screen. And in fact, in the hierarchy, you see nothing. It's just empty, right? Now, this is Unreal Fest. Now, if I do the same thing in Unreal Engine, and when I was using Unreal Engine for the first time, I opened up an empty scene and I clicked on play. Suddenly, the outliner is populated with stuff I did not even add. And this confused the hell out of me. Like, why does this even exist? How many of you got confused by that the very first time? Like, yeah, I didn't add that to my outliner. What is going on? And this is, in fact, one of the biggest differences between Unity and Unreal Engine, in that Unreal Engine takes care of the boilerplate code for you. Now, what is this boilerplate? Now, almost, I would say, all games have this going on, right? They have game rules. They have a player or players. They have a player camera, player information, where you're storing the player information like name, score, user-specific information. You have UI, which is some kind of user interface. You have inputs from the player. And of course, you have a starting position of this player. And this is true from any kind of game. This is not just an FPS game. It could be an FPS game. It could be even be a match 3 kind of a game. You still have these things going on in these kind of games. And this is exactly what is auto-populated in the outliner, because you see, when you see the outliner over there, game rules are stored in what is called game mode base. Players is the default pawn. Player camera is the player camera manager, or managed by the player camera manager, and so on and so forth. So what Unreal Engine is allowing you to do is just help you concentrate on making your game while all of the boilerplate is taken care of for you at the very beginning itself. Obviously, if you're going to be making your own game, you want to be modifying these settings. So you can go to project settings and then go under maps and modes, and then you have all the default game mode and you can change them. And it just works automatically. Actually, you know what? I hate that word. I don't believe in magic at all. I don't like when someone says that it just works, because I'm a programmer. I like to see under the hood. I want to see what exactly is happening. Why is this things being populated in the outliner and so on? So I delved into it. Now, if you are curious like me, the source code of Unreal Engine is available for everyone to look at on GitHub. So if you go to the world class, world.cpp, this is the class that gets instantiated as soon as a level is loaded. And in there, you have something called authority game mode, which is called through this function called init game. And that's again in world.h, world class. So this is the first thing that gets called as soon as a level is loaded. Within the game mode class, or within the game mode class, game mode base class, you'll notice that when the initialization is happening, all of these, the default pawn, game mode base, game network manager, blah, blah, all of that is being called from over there. And that is why you see the outliner being populated by these things. Now, if you are a Unity developer and you're like, you know what, screw this, I don't want any of this boilerplate, you can comment it out. But that's a bad idea. Don't do that, because this is an extraordinarily powerful system, because what you're seeing in action is the very well-tested, extremely robust gameplay framework. Now, this is the backbone of game development in Unreal Engine. And Unreal Engine gameplay framework is this core set of classes and concepts that provide a very structured and modular foundation for building your gameplay itself. So it's like a really good starting point, like a really robust starting point where you have all of these boilerplates taken care of for you. You just have to add on top of it. Now, if you have gone through the begin play documentation on the Epic developer community, that's the same drawing or the graph that you would see, showing you how exactly is the gameplay framework being structured. And this is incredibly powerful, because whether you're making a game like Lyra, which is like a third-person shooter game, blah, blah, you're shooting, and then if you go under project settings, this is the same gameplay framework that's being used. So you go to game mode base, you define all of those things over here. Or even if you're making a top-down casual RTS game like Cropout, still uses the same framework. Nothing changes. Or if you're making a brawler or a FPS or a dungeon crawler, by the way, all of these are the new templates that were just shown during the keynote, all of them using the exact same gameplay framework over and over and over again. So you can just make any kind of game. So it's really scalable when you think about it. And again, any kind of game really. It's not just us using. These are all the games like Tower of Fantasy Hota or the Oregon Trail, Neelakantan, Fortnite itself, of course, all using the same framework. Or from our neck of the woods, Raji, which is I'm from India. So Raji is also using the same framework. Final Fantasy 4, Blue Protocol, all of them using the same framework over and over and over again. Now, in Unreal Engine, if you select all the objects in the outliner, you can see that I can, in the gameplay framework, when I click on play, I can select all the objects, I can move them around if I want to. And this brings me to the second important conceptual difference between Unity and Unreal Engine. Now let's go back to Unity, right? In Unity, the objects that you see in Unity, you call it a game object. So if I create, in the hierarchy, if I just create a new cube, that cube is a game object, right? Everyone knows that, I think, if you're all Unity developers. And if I want to move it around, I can move it around. Now, and all the properties of this particular game object are then handled in the inspector window, where I can just go in and add my own components, and I can modify components, or I can add new components, and so on. Now, you have a similar paradigm in Unreal Engine, where if you can see and move an object in the level window or in the scene, you call that an actor as opposed to a game object. And all the properties that you're going to be adding to the actor is an actor component. So I can go in here. If I want to add let's say a static mesh, I'm able to see this cube because I added a static mesh component. There's also existing actor components that you can use without having to write new ones by clicking on that little add button in the details panel. Now, in Unreal Engine, everything is either an actor or an actor component, literally everything, which is awesome. And they all inherit from the same object, which is UObject. Now, if you are a Scooby-Doo fan, which I think everyone are, you'll notice some old friends in this image. The same gameplay framework. If you remove the gameplay framework, it's just all actors and actor components all the time, the entire time. And since you have the source code, you can actually easily trace it. So you can see that all the default pawn, the game mode base, game session, HUD, everything is just right here. And everything, all the properties under it are also right here. And by the way, you'll notice that there is a player camera manager and U actor component. That is just a naming convention in Unreal Engine, which also confused me initially. Like, what the hell is A? A is for actor, U is for object. So anytime you're going to be creating new actors or new actor components, just use this naming convention so everyone is on the same page about it. When it comes to developer efficiency itself, there are a lot of similar-ish tools when it at least comes to the implementation of certain features within Unreal Engine and Unity itself. So you have, in Unreal Engine, you have chaos as a physics engine. In Unity, you have physics. UI input is common UI enhanced in Unreal Engine, and UI input or UI system and input system in Unity. Animation has, for making animations, you have sequencer, you have timeline in Unity. In shaders, you're using a metal editor. In Unreal Engine, Unity, you're using shader graph. Particles using Niagara in Unreal, and particle systems in Unity, and so on. But let's talk about some Unreal-specific tools which is unique to Unreal Engine itself, which help you boost your developer efficiency itself. So first off, we have this feature if you're making a mobile game where you're able to enable previewing of the game itself on the platform that you're going to be deploying to. So if you have Android, you can go to it's a new icon at least, or position with Unreal Engine 5.6, where you can just go in there and just say, hey, for Android, just select any of those preview platforms, or for iOS, you can still preview it. And it gets very close. If you look at the preview platform on Android, this is the default if you just click on play. But if you are going to be previewing on, say, Vulkan High, then that's what you get. Vulkan Low, that's what you get. So it gets very close to what your final output is going to look like. Same thing for iOS, where you have the default Metal High, Metal Low, and so on. There's also now official support for the Android emulator, which comes with Android Studio itself. Now, if you power up the Android emulator from Android Studio, and Unreal Engine is able to connect to the Android emulator itself. And this is super helpful because if you're making a mobile game, there's going to be hundreds, if not thousands, of varieties of mobile devices that you probably can't get your hands on. So you can use the Android emulator, which is actually a very, very close equivalent to the real mobile device itself, provided by the Android developers themselves. So if you're going to be just testing your game to see if your game works on a particular OS with a particular resolution, with a particular amount of RAM, you can now connect to the Android emulator directly from the editor itself. And talking about more efficiency, if you're a C++ developer, we now have this option which says don't bundle libraries into APK. Now, if every time if you're going to be deploying your game into a physical mobile device or even to an emulator, you don't want to be packaging all the assets if you're just making changes to the code. So if you turn on that option right there, or if you go to project settings and just check that button, you will not be bundling all the assets every time. You'll just be only pushing the C++ code, which is ridiculously fast, much, much faster than you having to package all the meshes and sounds and shaders every time you're just testing the game out. And I can already hear the artists going like, but what about us? Like, oh, I want to also be efficient or something like that. Well, don't worry about it. We now have Zen streaming. This is a very complex graph, so I'm going to break it down. Now, typically, when you're going to be creating or deploying a game, this is to a device, this is what happens, right? So you have the Unreal Editor.exe on the top, and if you're going to be pushing that game to a target device, it then converts and cooks the assets to the target device's configuration or to the target device's capabilities of handling that asset, and then it's going to deploy it, and then that's how you're able to then see that game onto your device itself, which is a fairly complex process. So you're doing cook at least one time. But now what Zen streaming allows you to do is, anyway, when you're loading the game into, or when you're loading the project into the Unreal Editor itself, it's anyway cooking that data. And that's the cooked data is on your PC or on your development machine. When you enable Zen streaming, you'll notice that the cooked output data bypasses all of this and directly streams that content from your development machine into your device itself. This is a really great tool for level designers, game designers, environment artists, because if you just want to see your level on the target device, rather than having to cook every time, you can just stream those assets. Let's see it in action, right? This is, again, crop out. Now you'll notice that I have connected to my mobile device. And on the top, you can see that this says, I don't know if you can see from back, but this says Zen server streaming. That means none of these assets that you're seeing there are in fact deployed to the mobile device. It's rather streaming from my PC directly into the mobile device itself, which means that it's super fast. So a game like, say, Project Titan or even like Fortnite, we were able to just test the game within seconds directly on the device itself, as opposed to having to cook every time. Now, enabling Zen streaming for mobile is super easy. Just go to the project settings and just enable Zen server, and then you have to add a couple of lines on the default engine.ini file, and you're done. And then that's it. And then you're able to just stream those assets from your PC into your device itself. To know more about it, yeah, scan the QR code. I can already see a few phones up, which is great. All right, I think everyone's done taking pictures. More pictures. All right. All right. That definitely seems to be a very popular request, I guess. Now, let's look into the second quadrant. So we talked about developer efficiency. You now know what the difference between Unity and Unreal is, and then you are able to also figure out like what are some Unreal-specific tools that help you boost developer efficiency. So now let's look at mobile memory and optimization, which also talks about asset management itself. And when you talk about assets in Unity, the building blocks of any game really is prefabs, right? So creating a prefab in Unity is super easy. Just create a game object, you drag and drop it into your project window, and you're done. And that's your prefab. And you can then edit this prefab and add components to its prefab and so on. But you need to understand certain things about Unity's prefab system itself. And that is, prefabs are flat in that they don't have your typical object-oriented inheritance built into it as a system itself. Now, you do have this concept of prefab variants where you can create these child prefabs, but they are more like templates of objects rather than supporting your typical object oriented kind of inheritance itself. So they're really not like true classes in the programming kind of sense. Now, heading back to Unreal Engine, for the most part, the equivalence of prefab is really blueprints. The blueprints are more structured, and in fact, they are fundamentally class-based. So they fully support inheritance in a very object-oriented fashion. So remember this actor and actor component I talked about earlier? You can see that in action every time you're creating a new blueprint. So if I create a new blueprint, you'll notice all this actor, pawn, character, which are all just inherited classes really from the base U object and actor class. You can see them in action when you're creating a blueprint class. And of course, similar to Unity, you can also add actor components by just going under components, and you can add any kind of properties to those blueprints itself. So in those senses, it's very much like a Unity prefab. But the real superpower that Unreal brings through blueprints is really blueprints scripting, which is the visual scripting that comes along with the blueprints itself. Now, while adding custom components in Unity requires C# coding, if you're adding custom logic, you don't need coding. You can just use this blueprints itself, which is blueprints visual scripting itself. Now, I know a lot of Unity developers, at least at the very beginning, gets very confused by this terminology between where people use the visual scripting of blueprint interchangeably with just blueprints as a prefab or as a template. Well, they are. They are very interchangeable because blueprints visual scripting is built into the blueprints prefab or the template itself. Now, blueprint visual scripting is incredibly powerful because you are able to ship entire games without writing a single line of code, just using this visual scripting language itself. Now, an example, if you're willing to explore it, is the Cropout. The Cropout sample project, which is available on Fab, is entirely written in blueprints, and it's production ready too. This also means that as an artist or a technical artist, you're able to contribute more into the game development process itself, rather than having to have a programmer translate your idea or translate your art into the editor through their own programming sense. And I'm a programmer, and for me, a spinning pink cube is amazing, and artists hate that. But now you're able to do it yourself, which is awesome. Now, here are some top 5 features within Unreal, within blueprints, which I really love. The first thing, I'm a programmer, so I don't like black boxes. So number 5, the source code is available for every node within Unreal Engine's blueprint. So if there's a blueprint, I can just double click it, and it just opens up the source code, and I'm able to understand at least what is going on behind the scenes. Number 4, similar to any kind of programming language, you can add breakpoints just like you would to debug C# classes. So here I'm adding a breakpoint to a branch node, and when the game reaches the node, it just breakpoints. And you can also, by the way, see the call stack of it. So if I go into the blueprint debugger, it also shows me where exactly is that node being called from, which is especially useful if you're using event graphs and so on, or event dispatches rather. On the same note, on number 4 again, it also helps you, blueprints also help you visualize logic. So if you're a more visual kind of a person where you want to see where the logic is flowing, you can see that in action also. So here, I don't know why that video isn't playing. Let me just go click that video to play. But here you can see that when I'm clicking on the, it is playing. So when I'm clicking on the villager to move, you can see that graph kind of just shows you where the logic is flowing. So that's number 4. Number 3, for all the DevOps and all the people who are wanting to blame other people for blueprints and nasty blueprints, there is actually an Unreal Diff tool, which is little less known, I would say, but it's awesome. It's built into the editor itself. So if you're using any kind of version control system, you're able to diff between what was written earlier versus what is currently there. Also compare between versions to understand what exactly changed within the blueprints. And number two is blueprints can be copied to a text file. How many of you knew that already? Only 2 people? Wow. 3 people, 4 people. That's still less. So that's pretty good. So if you take a blueprint, now typically if you're asking for help, I've seen people just take a screenshot of their blueprint and send it to whoever they're asking help to. But blueprints can actually be copied to a text editor. And in fact, you can even go to a site like the ueblueprint.com, I think. There's nothing to do with Unreal Engine, by the way, this website at least, Blueprint UE. But you can copy paste any blueprint into anywhere, including Unreal Editor, and it'll show you, and it'll paste exactly the nodes in that format, including the positioning of the nodes in however you copied it. So in here, I'm copying this entire blueprint, visual scripting, I'm copying it, I can put it on a notepad, and this is what you'd see. Of course, it's not readable, but this is now readable by both Unreal Editor and even any third-party tools like this website I was just showing about. Now, number one thing, now remember, I'm still on the quadrant of asset management, right? The number one thing I really, really love about blueprints is that blueprints are in fact treated like content. What does that mean? From a Unity point of view, you've all played around with asset bundles, right? Now, in asset bundles cannot contain assemblies. And that means that you cannot distribute any new C# classes or even change existing classes on the fly. Whereas with Unreal Engine, blueprints in fact compile down to bytecode. And that means that blueprints visual scripting can be packaged as DLCs or pack files in Unreal's terms. And so you can in fact have the game download the blueprint visual script that you have done after the initial binary has been downloaded. Now this is phenomenal, right? Like you can have logic which you can change later on and then just push, and as long as they are blueprints, you're just able to push them in. And this is what you're seeing in action. So in order to create a Unreal blueprint, Unreal DLC, you go to any folder that is inside your output, inside your project window, or in this content window. You're able to create a chunk, and then you're able to create priority, and then right there at the very bottom, you can say, I want to add blueprints, like explicit blueprints in this DLC, which is awesome. Now, things to note when you're talking about blueprints, when they're being treated as content is, one, blueprints can be added as DLCs, which is great. But if you're writing C++ code, that gets loaded upfront in the game itself. So that's part of your core binary. You cannot modify C++ code. And blueprints are only loaded as required, but they also are loaded, other blueprints are loaded if the first blueprint that you're loading has a reference to the other blueprints. So you need to make sure that your blueprints are as modular as possible if you want to have very lightweight DLCs. So if you have multiple blueprints referencing to each other, then your initial loading time would also increase because all of those blueprints are referencing each other at the same time. Now, if you want to know how those referencing will happen, we do have a very handy reference viewer within the editor itself. So if you want to optimize your blueprints, you can go to the reference viewer and see like what blueprints are referencing other blueprints so that you can reduce your load time as such. And if you want to know more about how to download these blueprints or how to download pack files in general, which is in Unreal term is called chunking, there is a very useful documentation here where it tells you how to host a manifest file, how to have assets that you can load on the server and then download them later on after you have downloaded the initial binary of the game itself. Now, how many of you are programmers here? And I can see you're screaming in your head saying, what about performance, man? Like blueprint performance, right? Right. Exactly. Well, blueprint performance is actually something very important, but you need to keep in mind that blueprint performance varies based on where you're testing it. Now, this graph, to walk you through it, this pink line that you're seeing, actually it's flipped, sorry. Uh, should be the other way. If you're going to be publishing your, or if you're going to be testing your game, your blueprints performance in the editor, it's going to perform very badly. It's going to be terrible. So as a programmer, you might say, "Oh my God, Atlas, that sucks. That's horrible." But if you test the same blueprint on a shipping build, it performs really, really well. So as a programmer, as someone who's optimizing your game, never test your blueprints performance in the editor. Always test it on the shipping build itself. But that said, C++ will always perform slightly better than blueprints all the time. But I think you have to have a balance between developer efficiency versus performance at any time of any part of the game that you're when you're building your game rather. So now let's take a look at managing memory, because we talk about memory. So let's talk about managing memory between Unity's C Sharp and Unreal C++. Now, whenever I talk to new programmers especially, they are afraid of Unreal C++ because C++ natively doesn't support garbage collection, and that's a huge plus in C Sharp or Java or any kind of this kind of managed programming languages. But Unreal C++ is different. Unreal C++ in fact comes with a garbage collector. And so any object that inherits from, remember the U object that I talked about earlier? Any object that is inheriting from U object, it's marked for garbage collection. So internally it uses a mark and sweep methodology to then mark objects that has reference or that don't have reference. After a certain period of time, it just clears everything, clears or runs the garbage collection, which is exactly like how C# really works, and it just works automatically. No, doesn't work automatically. Let's see how that works, right? And so with 5.4, with Unreal 5.4 and in Android, and Unreal 5.5 with iOS, we now have a new memory insights tool that allow you to see these kind of managed memory clearance itself. So for this demonstrative purposes, I just created a new C++ class. By the way, you can also notice that the same kind of hierarchy that we saw in blueprints also exists in C++ whenever I'm creating a new C++ class also. For this demo, I created like 3 classes, which is one is called my garbage collector object, my garbage collector actor, and one object that's referencing this actor. Now let's see what exactly I did. So there's a my garbage collection object, which just inherits a U object. It's just an empty object. It doesn't really do much. It's just an object. And this is what we're going to see garbage collected. Now in the garbage collector actor, which inherits an actor, I'm going down and I'm creating a new variable, which by the way, I have annotated with the attribute U property, which is what marks it for garbage collection. And I have that U property as my garbage collectible object, which is what you see over here. Once I have that, I am just going to go to my actor class and I'm just going to instantiate it. Now, it's very important in Unreal C++ that you don't use the new keyword. Rather, you use the function called new object in order to instantiate a new class, because that's again how the internal garbage collection system understands that this has to be garbage collected, or it has to be managed by the garbage collector itself. So once you use the new object, which is what you see over here, that's how you're instantiating that object I just created, and now this object is now eligible for garbage collection itself. Now I'm going to create a new actor. I'm just going to right click, I'm just going to create a new blueprint, and this blueprint class is going to be the C++ class I created. So it's going to be this garbage collectible actor class that I just created. Just going to select that. Let's just call it something, BP underscore, I think I called it GC example or something. Yeah, example. So let's open it up, and you'll notice a couple of things. One, when you're creating a C++ class, C++ and blueprints love each other, by the way, blueprint visual scripting. So if you mark a function as a U function, it then gets called or callable from blueprints itself. So I called a class or a function called setup garbage collection, and I called it a U function, and you can see that I can then call the same blueprint over here also. I can see a lot of eyes going, oh, really? There you go, yeah. So if I create a U function, I can call it from blueprint. And I can also do the vice versa, by the way. So now that I've set up the garbage collection, I've now cleaned up the garbage, or rather cleared the object, set it up for garbage collection purposes. I'm just adding a static mesh just so that I can see it. So I've added a mesh. There you go. And now I'm just going to drop it within the new map. And now this is instantiating the new object I created. Now let's see it being garbage collected when I delete it, right? Now, by the way, if you go to the project settings, there is a engine garbage collection where you have the time between purging pending kill objects, which is, remember I told you about the mark and sweep algorithm for garbage collection? The mark and sweep, the marking happens immediately, but the sweeping happens every 61.099 seconds. You can change it to whichever number you want, but that's the default that you see within the engine. So let's see it in action. I have this game. This is on my Android device. That's the same object I created. And on the right-hand side, I can see, I can see the, why is it not playing? Let me play that video. On the right-hand side, you'll see that new memory insights in action also. Play that and play that. Is it playing? I don't know why it's not playing. Well, that's how you figure out memory optimization in PowerPoint. But you'll notice that as soon as this video is playing, I just sped it up a bit. But the important thing that we really care about is this U object that you see right there. And I'm going to pause right here. So there is a U object that you see right here. That's what I know a lot of people in the back can't really see, or even in the front can't see it, but trust me, that says U object. And at the 61st second, which is 1 minute away, you'll notice that this U object graph suddenly dipped. And that means that our object got garbage collected. And that's proof to say Unreal's garbage collector works. And you can also run memory insights on your game to, in fact, track individual objects. And this has been an incredibly powerful tool for us in Fortnite to figure out all the leakages, memory leakages that we are seeing on mobile itself, because PC console, I think it's a little more liberal with these things, but with mobile, every byte matters. So that's how we're able to find out. And so it's important that when you're creating new objects in C++, that you have these kinds of new properties set up. And this is, by the way, well documented right here. So this is an Epic developer community document that I wrote, where it talks about how to set up memory insights and how to set up tracing for these kinds of memory insights for Android, and it also kind of extends to iOS also. So you can check it out. So you can track every bit of memory that's being captured or that's being used within your game itself. I also wrote another big topic. It's in fact asset optimization. Like, how do I make my asset sizes smaller? Now, this is a talk I've given a couple of times. So I also wrote an Epic developer community doc, which is here. And if you're more a person who I want to hear Arvind talk about asset optimization, hey, there you go. So in Unreal Engine Fest Seattle, I gave a talk on how to reduce your build size itself. So I don't want to go repeat it again, but you can check it out. So you also understand how to make your mobile game as small as possible. So I'll let it out there for a bit. Just looking at time. Yeah. All right. All right. So now let's go to the third quadrant. I think a lot of people were like, oh, right. That we were in these quadrants, right? Yes, we are still in this quadrant. So we are in the third quadrant. So we talked about developer efficiency, we talked about mobile memory and optimization. Third is visual fidelity and rendering. Now, in Unity, you have two render pipelines. You have the scriptable render pipeline. One is the HDRP, which is the high definition render pipeline, and then URP, which is the universal render pipeline, and both they are very good. The downside of that is if you're making a PC console game and you chose HDRP, then if you want to convert that game to a mobile game, it's hard to say the least. You can't switch from HDRP to URP easily at the very least. And that's not really ideal. And in Unreal Engine, that's not a problem because in Unreal Engine, we have something called the unified render pipeline. And it's the same pipeline that exists between a mobile game, a PC game, console game, a Switch game, any kind of game. So remember the quadrant I talked about earlier where you shouldn't be branching to do your game development? This is amazing for that because with a single pipeline, you can start creating a PC console game at the beginning, kind of like what Fortnite did, and then decide later that, hey, I want the same game on mobile too because I see a large audience there. No problem. Just use the same pipeline. And all the pipelines work the same way. Starts with number 1 through number 10, all the way from scene prep and occlusion all the way to post processing. And the visual fidelity or the parity that you're able to get between PC and mobile using this unified pipeline is just phenomenal. On the left-hand side, this is, by the way, Unreal 4.27, not even 5. This is Tower of Fantasy Hotter game. Not This video was not made by me. It was made by this guy called Dear Impact on YouTube. So on the left-hand side, you can see the mobile game running. On the right-hand side, the same game on PC running. And the visual parity is very close, right? And it's only getting better and better as the Unreal Engine versions keep upgrading. And this is, by the way, one of my favorite examples too. This is from Netmarble's King Arthur Legends Rise, and this video I'm going to play is directly from the mobile device itself. Pretty awesome. I think it woke everyone up. They're like, oh, what? Dragons. And so this was from mobile device, again, from an older version of Unreal Engine. So just to show you that, yeah, we've always been looking at mobile all the time. Again, more screenshots from the same game. Another game which has been making the waves, I guess, is Wuthering Waves by Kuro Games, also on mobile device using Unreal Engine. So what's new about, like, all of these are like, in fact, older versions of Unreal Engine. So what have we done with the newer version of Unreal Engine 5.5 and above that allows you to maximize your performance and rendering features within Unreal Engine itself? And there's a lot of things that happen, but I just want to call out GPU scene, ISM, which is instant static mesh GPU culling, landscape GPU culling, and forward light optimization. Now, what exactly are these jargons that I'm talking about? Now, what is GPU scene? Why do you need it? Now, in short, GPU scene is this collection of GPU buffers that pretty much holds all the information regarding your actor within the scene itself. So it contains information, or it stores information like its location, rotations, transform information, and all of those kind of things. Now, when you enable GPU scene or you enable auto instancing or dynamic instancing, what this allows you to do is it merges all of these actors into a single, or into a or as low as possible, in fact, or single draw calls, which means your performance on your mobile device just increases quite a bit. Now, this GPU scene or auto instancing has been around on PC and console for a very long time. So if you're PC console developers, you're like, yeah, it's nothing new about it. But this didn't exist on mobile, so we had to find a few workarounds, and now this is available on mobile also. Now, because of GPU scene, we also now have other rendering techniques like instant static mesh, where you have per instance culling for all of the instant static meshes, uses GPU scene behind the scenes. We also have instant static mesh with GPU, like auto loading for through GPU scene. So if you have multiple meshes, then depending on how far the object is, it does auto loading, which is awesome. Again, a big performance boost on mobile devices. The same technique is also used on landscape meshes. So if you're creating, I don't know, Legend of Zelda 2, 3, 4, then you could, or 500 really, then you could enable GPU scene, and you have the same technique where each of these terrains are cut into quadrants, and you're able to then, behind the scenes, the engine just takes care of the auto loading and performance as such. A big question I get asked all the time is Nanite and Lumen on mobile, um, which is in works. So we have desktop deferred rendering, which is currently experimental. Do not use it in production yet. But if you have a fairly high-end device, a mobile device, you can enable desktop renderer on mobile, and then that will enable the desktop deferred rendering, and then you can have experimental versions of Nanite and Lumen working on that device itself. And final quadrant, we're almost running out of time, which is third-party support, because that's when you're making a mobile game, you want to have in-app purchases, notifications, ads, and so on. So let's talk about that. So a less evangelized part of Unreal Engine itself is all of this, in fact, have native integration. So if you look at blueprint node, there is an existing blueprint node called show ad banner. If you have like ad mob integration done within Unreal Engine itself, so you can show ads, hide ads through blueprint visual scripting itself. Means showing ads is pretty easy. Same thing with in-app purchases. So there is in fact a wrapper class for in-app purchases itself. Whether you're using in-app purchases in iOS or Android, you can just have the read in-app purchase information node called, and you have a data asset that kind of defines what those in-app purchase IDs are for iOS and Android, and it just reads it, makes sure that all of that works. And so this exists too. Hey, all right. Third, notifications. So there is again an existing node called show local notifications or schedule local notifications and hide local notifications. All of that exists within the engine itself. This is all cool, but what about third-party SDKs? And that's actually been a big complaint within Unreal Engine community itself, is saying, hey, I want to integrate some obscure SDK or some probably well-known SDK, and they don't have Unreal Engine support. They have maybe Unity support or Godot support. What do you do about that? And that's why we have API Gear. Now, API Gear is an open source tool maintained by Unreal Engine, and this this essentially generates plugins for you. All you have to do is define the API or describe the API that you're getting from, say, I don't know, Netflix or anyone else. Describe what that API looks like, plug it into API Gear. API Gear will auto-generate Blueprint and C++ classes, whichever you prefer, and which will then once you have that generated, your plugin is ready. Then you just put it inside your game and you're done. So this means that any kind of SDK doesn't matter. You can just use API Gear and it just plugs in inside your game, which is pretty awesome. So that pretty much wraps up my talk. So let's look at the technical expectations, kind of going back around, right? So when you look at the developer efficiency, like how fast can you deploy games into your mobile device, how efficiently can you work as a team, that's kind of what we covered for both Unity and Unreal Engine. And then mobile memory and optimization, how best can you track every object that you have created within your game, and how best to optimize your assets. We covered that too. We talked about just the inbuilt visual fidelity and rendering that Unreal Engine is able to give automatically right out of the box, and not just Unreal Engine, also what Unity does behind the scenes. And finally, third-party support like ads, in-app purchase, and notifications, and also third-party libraries. So in all of these four quadrants, I think Unreal Engine does a pretty good job when you look at it, kind of tapping on all these four quadrants, which is the lens through which you would typically be looking at when you're picking up an engine for your mobile game development. Unreal Engine kind of checks all the boxes, I think. So I hope that you now understand why when you click play on an empty scene in Unreal Engine, you just see like things auto-populated, because you're building on a very, very robust framework, which is the gameplay framework. And the idea when you're making a mobile game in Unreal Engine is just for you to just tell your story, rather than having to build all the boilerplates from scratch over and over again. In addition to this gameplay framework, we have other frameworks too, like on the right-hand side, you'll notice that, hey, we have like Mass AI, which allows you to create AI crowd simulations, for example. You also have the gameplay ability system, which is quite talked about during the keynote. And there's also, in fact, a lot of talks even at the fest about the gameplay ability system, which allows you to create any kind of game asset or data management in a fairly easy manner. So do check that out too. And at Epic, we don't just provide Unreal Engine, right? We in fact provide you an entire ecosystem of tools that help you make the game. So we have Unreal Engine, which is one component of what we provide, but we also have Twinmotion, which allows you to create environments for your artists without, again, writing any code. It just automatically makes it look pretty. We have content libraries like Fab, both third party and first party. We have services like the Epic Online Services, which allows you to create multiplayer games very easily using the Epic ecosystem. You can distribute your game through the Epic Game Store, and if you make a UEFN game, you can even distribute it in Fortnite. And of course, we have a very large community right here. And you can also reach out to communities online. If you're a developer on the Epic developer community, or if you're an artist, you can go to ArtStation to also show off your work. And if you want to know more about mobile game development, check out this fairly new Epic developer community post, which helps you get started with mobile game development. You scroll all the way down, you'll notice a familiar face where I have just said like, hey, here's the video content of this. So this is here. And as mentioned, there's also a brand new sample. As of yesterday, we have this new parrot game. I don't know if it's called parrot game or pirate game. There is a parrot pirate, I don't know, something. But that's a game that's both on Unity and in Unreal Engine. So you're able to kind of, as a Unity developer, kind of see what is the difference between those two games itself. And you've made this game. Now you want to get more engaged with the community. There is a very amazing community called Epic for Indies. I also take care of the India part of it, where we have like monthly office hours where you can talk to engineers within Epic to ask questions. I get very confused by India Indies or India. India is just like, but that exists. So definitely join the Discord channel and talk to other indie developers itself. And once you have made your game, boom, publish it on mobile on the Epic Game Store, which is available on iOS and Android. iOS in certain countries, Android globally, which is awesome. So with that, thank you very much. I hope. Thank you. All right. Thank you. I hope that you have a very clear understanding of at least basic fundamental understanding of differences between Unity and Unreal Engine, and I hope that you have a fantastic the rest of the Unreal Fest in Bali, and I hope to see you around. And if you have any questions, do we have time? Outside. If you have any questions, you can go outside. No, I'm saying no. But I'll also be outside. I won't be inside. So thank you very much. Yeah.